Good morning, everyone. My name is Ilir Beyleri. I'm a faculty with University of Florida, and I'm the director of the Signal 4 Analytics program. I will be teaching this webinar today. With me is also Dan Brown of Signal 4 Analytics.
Good morning.
Dan will be answering the questions as we go and be available for any other assistance during the webinar. The webinar format is set in a listening mode. The communication with us is conducted through texting. If you hover at the bottom of your screen, you will see a toolbar as showing in the screen right now. And there are a few buttons there. We recommend that you focus on the Q&A button. We'll keep an eye on it. And as you ask questions, then we'll respond. You should be able to see those in real time. There is also a chat button. I would suggest using that for technical issues if you can't hear or have any other problem attending. There is also a raise hand button, which we have not been able to use it for any purpose. So you don't need to raise your hand, just simply submit the question, or if it has to be a side conversation, then you can click on the chat. We'll respond to the question during the webinar as we go in writing, or if there are questions that are more or less around the same theme and we have time at the end, I will respond to them verbally. Also, for any non-pressing question, you can email me at any time at this email shown on the screen, ilir@ufl.edu. For folks that may not be hearing us at the moment, hopefully they can see this screen and there's instructions there on what to do to address the audio. The best place to go is to this button, Audio Settings. Click there, and you can adjust the computer speaker. If you're listening through your computer speaker, make sure to pick the right speaker. Or if you're on the telephone, or you can leave the computer audio and join the telephone in the telephone. If you're hearing me just fine, then you don't need to worry about this. We will record this webinar as we've been doing for the rest of the webinars, and they will be available for viewing afterwards. In addition, afterwards, all the participants will receive the PowerPoint slides that are applicable, the list of questions and answers, and a link to watch this recorded webinar. As I'm getting a question for my email. Let me put my email back here for a second. Okay, there's my email address on the screen. It's ilir, just like my first name, @ufl.edu. So as we have announced, we've been teaching 4 sessions of this to cover the Signal 4 Analytics entirely. Yesterday we taught session 1 and 2, which focused on an overview and basic features as well as the more advanced features on Signal 4. Today we'll focus on network analysis, and this afternoon we'll focus on citations and reporting, which is new to Signal 4, so that would be useful for anyone that I guess would be useful for everybody, since those features are not posted yet. So in today's session, we will focus on network analysis. Network analysis is a feature designed to focus on the network rather than the crashes. It obviously looks at crashes, but it finds high segment crashes or high intersection crashes. using various measures such as crash count, crash severity, crash rates. So we'll see how we accomplish that, and we can see how we can review those particular segments and intersections of interest. We'll spend a little more time on the analysis filters for the network analysis, and at the end we'll show you how you can download the ranking of your network, which means how you can download a spreadsheet of the top 5, top 10, up to top 20 intersection, a list of top 20 intersection, a list of top 20 segments, and actually it can go up to top 100. Before we start, I wanted to do a quick poll to find out where the audience stands as far as prior experience or knowledge about Signal 4 analytics. So you'll see on the screen something like this. And once I put it up, please vote real quick, anonymously. All we need to do is get a sense of your knowledge so that then I can pace the webinar for the rest of the session more efficiently to serve you best. So I need to start this poll, launch polling, and here it is, it's launched, so please go ahead and vote. Okay, we're about 70% of you are voting. Okay. 82%, please keep voting. 81, actually. 82 now. So I'll leave it up here a few more seconds, and I'll share the results with you in a second. Looks like we're topped at 84% voting. So let me end the poll and I will post the results. So you should be able to see the results now. As you can see, we only actually have a small number of folks actually using it occasionally and some using it more frequently. But it looks like the majority of you either are new to Signal 4 or didn't know that it was there or simply have not used it. So this would be a good opportunity to learn something new, which we think is valuable for anyone that has a stake in improving traffic safety. So I'll take a screen capture of this for our needs. And I will stop sharing the results. Thank you for participating in this poll. Let's get back. So if you participated in previous webinars, you know that all the demonstration is live. I teach this by showing you how to use the system directly in the interactive system. So I will do the same for the network analysis. And I should start here. So when you log into Signal 4, you see this familiar view. At the top, up here, there are 3 buttons. Used to be 2 for quite a while. There is a new button called Reporting, which we will look at tomorrow, later today, in the afternoon session. But today, for this session, we'll focus on network analysis. So if you hover over, you see it gets a little color, and all you got to do is just click on it, and it goes in and runs an automated query and shows you the top 10 intersections in the geographic area of interest. It takes the geographic area from whatever you were doing on the event analysis. So I had selected Alachua County. So it went in and pulled the 5 top intersections in Alachua County for year 2017. So I'll go in detail and explain this, how it works. So let's look at the map first. You can see that it places a little bubble with a number at the applicable intersections. And the number shows the rank. So the lower the number, the higher in rank. So the intersection with the most crashes is number 1, and that is this intersection over here. If you're familiar with Gainesville, then you probably are not surprised. This is the intersection of Southwest 34th Street and Southwest Archer Road. The listing of attributes for each of these 5 intersections is over here in this, what we call the data grid below the map. So for this intersection, number 1 here, ranked as number 1, you can hover on the bubble and it will get a little tooltip that gives you some basic information, but also the same information you can see here in the data grid. So let me explain this in more detail. So first column is the rank, which is, as we said, number 1. Second is the intersection name. In this case, you see that there's State Road 121 and State Road 24. Plus you got, for the roads that have multiple names, it uses all the names that are available there in the database. We have a crash count, crash frequency of 93 crashes in 2017. This is crash severity. It's a measure that takes into account injury severity based on a formula. I will be showing that a little later. And it gives you a measure. You'd see that this probably is not the highest. For this intersection, crash severity is 216, but for the intersection ranked as 5th, crash severity is it's higher. That's because when this query runs by default, it ranks the data by crash count or crash frequency. The next field up here is crash rate. Crash rate takes into account traffic volume. At this time, we have not applied that measure because traffic volume has not been available, but it is now. It is in our database thanks to DOT Safety Office provides the DOT Safety Office has enhanced the unified base map that's behind the scenes in Signal 4 with some variables from the RCI, Roadway Characteristic Inventory for DOT roads, and one of them is AADT. So we will be applying that measure here, plus some counties that we're working directly with, Metroplein County, the 3 Metroplein counties and Brevard County. They also have traffic counters, local traffic counters, so we'll be including those measures as well. And I'm sure there is local traffic volume by other counties in the state. However, unfortunately, at the moment, there is not like a central place where all that information can be shared and be used here. However, we are in discussion with DOT. DOT is interested in those measures as well. So hopefully we can, at some point, we'll have a more like a central place where we can get access to that information in the future. Other measures here is number of fatal crashes. Fortunately, none of these intersections included one. This other measure is fatal and incapacitating injury crashes. So this would be the column that we refer to as serious crashes. So you can see you have some numbers in there. This represents crashes that had some sort of injury. PDO crashes are property damage only crashes. As you can see, that's the majority. Then other measures include the bicycle pedestrian crashes, the total number of vehicles involved, the total estimated damages based on police reports for all these 93 crashes shown here, the city, the county, and the roadway classification. Roadway classification is done by following the classification in the crash report. There are several classifications for roads. You have the federal classification that is typically used by DOTs around the country, including Florida DOT, has about 13 different classes. That is mostly available for DOT roads, but it's missing for local roads. So now that along with the AADT that I mentioned earlier, that classification is now also available in this all roads base map that's used by Signal 4. So we'll be looking to offer more than one classification, roadway classification for the system. The other one that's available is the functional classification of the HERE GIS database, which is the commercial roadway database that we're using behind here that's been enhanced with additional variables. Theirs run from 1 to 5, but we don't find it very useful, and most people don't find it really very useful for analysis, for the typical analysis that we're used to do with crashes. And the third one is this classification based on the crash report. So if you pay attention to this is the filter panel at the bottom, has the roadway classification. If we click on it, these are the various classes that are used in the system. So it'd be interstate, US road, state road, county road, local road, and also if there is a turnpike toll type of road, or other at that point, if it's none of the above. I should point out that Dan's reminding me to say that for intersection, since intersection involve more than one road, the roadway classification is the highest roadway of the roads entering the intersections, right? So where you have an intersection that involved a state road and a local road, then the roadway class will be state. And then on the right here, the third portion of this interface is the query panel. This is what you'd use to basically pick the time period of interest for crashes and the network features of interest. So at the top of the date range, we have options to choose the starting year and the ending year. We say date range, but it's really by year, because when you do network analysis, typically it's done using year as the basis, because that's where it makes sense when you include things like AADT or even, crash severity. So anything else, if you want to look for sub periods of time, most of these measures won't apply. Therefore, we decided to just stick with the year as the unit for this analysis. This is how it's traditionally done as well. So you could choose a time period. For example, if I wanted to do 5 years of data, I can go from 2011, say, to 2016. Right now, you can see that the highest available is 2017. We have aggregated and prepared the data for 2017 as well. That's why it shows up there. However, I should point out that typically at any given year, it takes a while for the Department of Highway Safety and Motor Vehicle to close the year, as that's the term that's used, because there's more reports coming in. Even, for example, in 2018, there's still reports coming in for crashes that occurred in 2017. And therefore, it's difficult when to make the call to basically run all these calculations for each intersection and segment. Typically, the year is closed in August or September of the following year. So 2017 will not be closed until then, August of or September of this year. So we went ahead and did an initial aggregation for 2017 because most of the data is there, but still there's more data coming. And we will rerun the aggregation and rerun these calculations again when the 2017 is closed. And sorry, here I said 5 years of data, but I think this is more like 6, so we ought to go 12. If we go 2012 to 2016, then we have obviously 5 years of data. Other options here is geographic area. Here's what's available. You could do this analysis statewide. You could do it by a DOT district. For example, if you wanted to look at District 2 or any of them, you would choose these and run the query. I will stay with the Alachua County for this for the webinar, but I would encourage you to play around with it to whatever geographic area meets your need. The other option is the MPO, and there's all the MPOs listed, so you could choose the one that interests you. County, even city, right? So you could choose, if you choose city, pick the city from this alphabetic list. So if I go back to Alachua County, by the way, there are 2 options for each county. We've mentioned this probably in the first webinar, but I'll reiterate it. You've got the entire county, including everything within the county boundary. Or if you are interested in only on the unincorporated area of the county, then you have the second choice. Unincorporated includes everything but areas that are within city limits within each county. So for now, I'll just go with Alachua. Then the third option here is the network feature that we're looking at. Am I interested in intersections, or am I interested in roadway segments? Or if I'm obviously, I could do each of them one at a time. The other option is the choice of numbers. So we've made available top 10, top 5, top 10, top 25, top 50, and top 100. So you could use this not only to find, which are these intersections or segments, but even as for something as more basic, like just get a list out of this. I'll show that toward the end, how you can export this list out and then use it in various reports or for whatever need you need to accomplish. When we do intersection, I'll still leave the top 5. We have an offset. We have 2 options for an offset, which means we're not only including in this analysis, when we find the top 5 for each intersection, we're not only including crashes within the intersection boundaries, but crashes that are in proximity to the intersection in all directions toward that intersection with a distance of 250 feet. This is a standard measure used also by FDOT, but depends on your geographic area. We added a 150 option as well. For example, if you're more interested in bike-ped crashes as opposed to all crashes, or if your study area, it's a city that's particularly urban, right, that have small blocks, then you probably could consider using the smaller measure because it will pick crashes that are more related to the intersection. 250, sometimes a whole block can be 250 feet, so if for urban areas, so that may not be applicable. I'll just leave the standard measure for now. And then last, you have ranking options, whether you rank the results by crash count or frequency, crash severity, injury, fatal crashes, fatal and incapacitating, or bicycle pedestrian crashes. Then there is another panel here that can establish your minimum crash count. We know basically that when you put a 5-year period like that, the number of crashes is definitely going to be high. So especially if you're choosing greater than top 5 or greater than top 10, then you probably want to limit this to a certain number. That is something that you can play around with, or increase it or decrease it, and you'll find out basically what the results are. Last, the roadway classification. I already explained that. Right now, this query applies to all roads. So what we're seeing here is, or what we will see is high crash top 5 intersections in Alachua County for years from 2012 to for a 5-year period from 2012 to 2016. So I'll go ahead and run it. Remember, what we have on the screen was applicable to 2017 only. So you can see it's a different picture. Right. For this 5-year period, we have different results, although this location still remain the most problematic location based on crash count. And you can see it has 263 crashes. So how do we study these more closely? You can either click on the bubble. I haven't clicked yet. It's simply I hover it. When you hover it, it gives you the pop-up, but you have to click on it. Or you can come and click over here where you could see it better. You have more information. So let me go ahead and click here. What it does now, it zooms to that particular intersection, pulls all those 263 crashes for you automatically, it plots them on the screen, and zooms to the area. It lists all the crashes here at the bottom, and then the charts now become available. This portion from this line here to the left should be familiar to you by now, right? Because this looks like the event analysis, which we covered yesterday in 2 webinars. The event analysis is where you can look at crashes and do all sorts of queries. Because we're focused on this specific intersection, it brings this information easily in the screen for you so that you can study this further. So what are the options that we have here? Well, you have the familiar options that you've seen under event analysis. First, let me change the map, the base map. At this point, we're close enough to where having aerial photography would be useful, because now we can start to see the built environment around this intersection, right? And it gives us a better view of the distribution of crashes around it. You can zoom in, zoom out as you like, obviously, and use these buttons here. For example, if you wanted to print the map, as I showed yesterday, you could do that. And between the map that you print, the crashes that you can export out here using the export data button, and some of these charts, which there are numerous charts you can create, you can start to put together a picture and tell a story about what's going on this intersection straight from using information from Signal 4. I know that there are more advanced users that would like to take the data into a third software package like Excel or ArcGIS, or maybe a statistical package, and do more advanced analysis, which is perfectly fine. But for most people, I just wanted to point out that there's a lot here that you can use to make your case or to prepare a PowerPoint or a report about what's going on at this intersection. So first, let's take a look, use this Google Street View to take a look at this intersection on the ground. So you can click anywhere on it, and then you hit the Street View. So this is from actually an aerial photography from another source, which is from Google, and it has a flat view like that. Or if you click on this little button again, you get more of a 3D view. As you can see, you can start to see basically the sides of the building. I'd like to point out that at the bottom of the screen here, you can see that all these crashes are mapped, and it's important that the crashes are mapped correctly and timely. Alachua County has in-house staff that basically maps this data every day. Therefore, their database is really up to date. Now, we do load the data every day as they come from Department of Highway Safety and Motor Vehicles. But as I mentioned before, not all of them are mapped automatically from text address to a point on the map. So some fail and they need basically editor attention to be able to be corrected. I'd like to take this opportunity to reiterate what I said yesterday, that crash mapping is a big issue, and there's efforts going on to improve it. DOT's got effort going on with editors. So we would like to do a separate webinar on just mapping so that everybody understand what goes on and with the quality of the data that you see on the screen, so that you all are aware of what you're looking at. So coming back to the point that I was making, if we can drag this little guy in here, then we get the familiar Street View from Google Street View. So you could basically, you don't have to go to the site right away. You could do a preliminary analysis of this intersection here with the information that you have. And then once you've equipped with all this data, of course, you may want to do a site visit to understand better what's going on over there in terms of the configuration, the signal timing, and how people use that intersection, and so on. So I'd like to jump over here to the charts to see what these charts can tell us about these particular intersections. So you see a chart of the distribution of crashes based on the time of the day. We can see distribution by month. So apparently we've got more going on here in the month of February. I'm sorry, distribution by year. So we see that the crashes actually increased. We see a dip in 2014, but then there is an increase in 15 and 16. We can look at crash type, and you can see that, by the way, this panel is resizable, so it's precisely for the purpose of giving you the opportunity to see this better. If you look at this, most of these crashes are rear end crashes, right? Then you have same direction side swipe crashes. You have some other which we are unable, or they were defined as other. And then there's some that are still unknown, which means that we were unable to define the crash type based on the algorithms that we've developed. As I mentioned yesterday, if you attended, the crash type, it's not an attribute of the Florida crash form, it's a derived attribute. We have developed an algorithm since many years back, and it takes into account many variables and determines the crash type. So if you wanted to see further, say, the same direction side swipe, well, where are these crashes? Do we see anything that's dominant? So there they are highlighted on the screen. And if you remember from yesterday, if I just want to look at these only, then you would click on this little button here at the top. You have this vertical toolbar on the map, the very top one, control the visit what you see, whether it's all or selection only. So now there's the selected crashes. So, I don't know if you can make much of it. I don't see anything, at least visually, that dominates here. But clearly, most of the crashes are occurring within the side swipes within the intersection boundary. Maybe due to some of the mapping limitations, some of these probably are on these legs rather than inside the intersection, and that basically you have to study it more deeply and pull these up and read the narrative. That's what traffic engineers do to fully understand what's going on. But you've got the opportunity to basically try to understand, get more information straight up here in Signal 4. Once you're done studying this, you can clear the selection and return to all crashes by clicking this little X, red X button in there. And here we are back. Another thing I wanted to point out here is that there are other attributes that you can look at. For example, see if there's many alcohol related. Unfortunately, there are 8 of them that involve alcohol. Let's look at crash severity. Fortunately, most of them have no injury, but you've got some, 21 of them, that's non-incapacitating, and then 5 that are incapacitating injury. And looks like there are no fatalities, fortunately. The other instrument here that you may want to consider when you study this intersection is to use the 2D chart. That gives you a combination of 2 attributes. For example, right now, by default, it's showing you distribution of crash type by crash severity. So you can see most of them are no injury, rear end, no injuries. But you've got 36 same direction side swipe that are no injury. And there are some side swipe like these 3 that are possible injury. So likewise, as we did before, you can click on any of these bubbles and the corresponding crashes will show up on the screen. And then, by the way, as you know, you could click at any of these and pull up the police crash report and study them more closely. Like this one has a north here, it's pointing west, so you have to rotate it if you want to have it to match more or less the direction that's expected. We expect north to always be pointing up, but that's not what you always see in these crash reports. And you can try other combinations here. For example, you can look at crash type and direction of travel. Let me clear the selection. So you can see, most of these are traveling east, for example. So we're starting to see something now, right? So if we click that, apparently most crashes tend to be traveling east, but also, west. I mean, there is a difference, right? But you still have quite a few also going west. So basically, I'm trying to point out that you've got an array of tools here to focus more and to understand what's going on in this particular intersection. Once you're done with that study, then you can come back to the intersection here at the bottom of the data grid, where you have the information for every single crash, as you're familiar with this from the prior 2 webinars. You can click back to intersection, and then you're back to the top 5 intersections in Alachua County for those 5 years. So let me switch back the map to cartographic. And by the way, if you would like the map not to be very dominant, you can also try a gray canvas, and that gives you a much more laid back map so that these locations stand out better. It's a matter of preference and need. So this is more or less what's involved to do a high crash intersection analysis in here in Signal 4. You could play around with these. I would suggest, for example, you can see, I think it's an important point to make, the roadway classification I've chosen right now, it's all. So there is no distinction. I'm not comparing probably the same road categories, right? So, but if you want to do that, then you have the option. For example, what would that picture look like if I just chose local roads? So I simply change the roadway classification and do search. You'll see that the picture would look different, right? Still, this intersection, it's in the top spot, but there are differences when you do this analysis. Let me focus for a little bit on this number 3 to point out something about the crash type. This particular intersection, it's a T intersection, and here if we look at types, you'd see a bunch of left entering. This is where I was talking about to see if you see any pattern, something that dominates that may need to be addressed. So in this particular one, left entering is essentially a left turn crash. If you are familiar with Gainesville, that's a bank on this building, and there is like a shopping plaza here. As you can see, there is a bunch of driveways going in and out this road. So if you're driving from this road going west, going left here, and it's not that straightforward. You can find yourself there a little bit concerned as you drive through it. So I'm not surprised that we have a bunch of left turn crashes here, especially as people turn this way with the traffic coming the opposite direction. But if you wanted to study those, obviously you would select those, and you'd see that there are a bunch that are at intersection, but there are a bunch that are over here, and some of these perhaps are not mapped as accurately, because right here there is this road that goes in the parking lot of this shopping center, and then turning left here, it's always a big problem, at least from my own personal experience. So I'm not surprised that we've got this distribution on the chart for these crashes. So let me go back to intersections, and let's look at the segments. The approach is the same. All you got to do is just change the segment, this network feature from intersection to segment. I'll go back and put the roadway classification to all. And the only difference here is that you don't have an offset, since we're looking at crashes at intersections, and the rest is more or less the same. Let me go ahead. I'm going to change this to 2011 for a moment, 2011 through 2016, and then click search. All right, so this is what it looks like. I asked for top 5, but I got more. So I've got actually more records in here. You can see that number 3, it's shared by 2 segments. They have the exact same number of crash count. So is number 4, right? So basically, although you're asking for the top 5, you will get top 5 places, which be a total records return could be more than 10. Let's look at what's reported here. So what you have is the street name. You have a definition of it at best that we could do. So it tells you where that is between which street and which other street. So it's giving you the cross street. Sometimes these are smaller stretches than between intersection, because the GIS database, it's segmented even more than between intersections in some places. So that's what we go by, what's in the database. And the measures are the same, right? The same measures we saw before, including the road classification. You can see most of these are state roads, right? But we have a local road in there, which is at number 4, Southwest 20th Avenue. I think it's probably the same location that I was showing you. Yeah, I think that's the same location where I was pointing out just a little earlier. So let's go examine this number 1. Again, you can click on it here, or you can click on the bubble. I'll click on the bubble this time. And there it is. This is let me zoom out so you can see where it is. So it's I-75 getting into Northwest 39th Avenue in Gainesville. It's one of those exits. So if you look at this, there are 152 crashes in this particular segment. And if we look at the chart here, you'd see that the primary rear end. So if we want to understand this more, we go to aerial photography, and I'll pull up one of the crash reports. If I click on these, I'll pull up any of these crash reports. I did one before we started, so let me show that. So that's the diagram that the officer drew at that location. You can see that it more or less matches what you see on the aerial photography. And then right there, there is a lot of rear end crashes. And that's why this is high in number of crashes. Most of them are rear end crashes right at that merge of this exit to Northwest 39th Avenue. Now, I thought there was something interesting here. If you go and look at year, notice what's going on. So apparently there were a lot more crashes in here earlier, 2011, and then started to drop, and you have more crashes in 14 and 16. So we definitely see a drop. There is a spike in 2015, but then it dropped again in 2016. And I frankly don't know what the history is there. I know that when I've seen there recently, it looked like freshly done work. So I'm assuming that, because this was identified as a problematic area, there have been countermeasures taken, which could have involved, I'm sure have involved some engineering, but also perhaps some enforcement, and the number has dropped. If I change this date range from 2012 to 2016 instead, and rerun the query, that location is not the first location anymore. The first location is in a different place. So it's Southwest 34th Street. And at Southwest 2nd Avenue. So let's go ahead and look at it. Again, if you're familiar with Gainesville, this is University Avenue coming, this road coming from UF, and this is Southwest 34th Street. This stretch here, it's pretty tight. There's not a lot of lanes, and has been a lot of work on the roadway. So you can see there's a lot of crashes in here in those 5 years, and there's the distribution by year, right? So you're seeing a drop and then probably a pick up again. So the number of crashes specifically here, I guess at this point, has not changed much. And I don't know if there would be any difference if we added 2017, but I will skip that for now. What I wanted to show you is distribution by direction of travel. And as expected, you can see most of the direction of travel is north, right? That's clearly a correlation of what we see with the actual data. So let me come back to all the segments that we've got so far, and let's see what the picture looked like for local crashes. Local segments. So we're comparing only local segments. Then you've got a complete different picture, right? These are the areas that, when considering only local roads, I believe this is that same area that we're looking earlier. that is close to that intersection. So let me go back. So this area clearly was problematic as far as intersection go, but as well as when you look at the segment itself. So it needs to be studied in conjunction, right? So it's important when you do these analysis to look at both intersection and segment, because in some cases you will find a match as the one that I pointed out here. Right here, for example, is that what I was talking about, the driveway going to the shopping center, and the left turns here quite a bit. So I'm just curious, if we go to crash type, again, there's the left entering crash type. If you attended the webinar yesterday afternoon, that's where we talk about the crash type and how we derive them. And then we have an actual document that if you went to event analysis under crash type, there is a little round button with an eye on it that you could pull up, and you'll be able to pull up this document that we have there. Is in PDF, and explains basically what's a left turn crash, what's a left entering, left leaving. These are detailed, but they're all left turn or left rear. All right. So just wanted to bring that to your attention. So if we go to a 2D chart on this location, then we can study this more to see if there is something that's different here. So we'll do a crash type with injury, crash severity, right? And maybe direction of travel, which you see a lot of these left entering showing up here, as we just saw. So obviously you could study these in more detail to find out what's going on in this particular location. If you wanted a distribution by year, I never did that. That's what it looks like. So fortunately, it seemed like we have a reduction more recently, and hopefully there'll be countermeasure applied there that can take care of these problems. Let me come back to segments once again. And one other thing I wanted to point out here is that once you've done your analysis, you can export the data out. So if I go in and do, say, all segments, or let me do intersection, I'm going to go top 10 intersection, right? Let me rerun this. Now you're going to see a lot more bubbles. Probably some will share the same spot or not. Then you can export this ranking out right here in the lower left corner. Hopefully you can see this. It's at lower left corner of the data grid. There's the export data button. You'll click on it and then simply download it as a CSV file. So I'll call this Alachua Top 10. Give it obviously a meaningful name and then save. So let me pull it up so we can see what was saved. That's the file that I just saved. Open it up, and that's what it looks like in Excel, right? I'll make this a little more descriptive. So there you go. You've got the intersection name, count, severity, crash rate, fatal crashes, and all the other measures. There are some additional attributes that we added here that you didn't see in that list. Are all these that have to do with the mapping of that, the centroid of the intersection, just so that if somebody wants to put this in a GIS, they can simply use either these two fields or they can use these two fields to plot the centroid of the intersection in their base map. Another thing that I notice here is the road class is giving you numbers rather than names. That is something that has skipped us, and we are correcting that so that you can see the actual name of the road class rather than number. However, obviously you have that on the screen, so you can make that connection relatively easily by which one they are, right? So I guess 3 is the state. So this is more or less what I had planned to cover. I wanted to show you the formulas that we use. So there's 3 variables that we use, crash rate, essentially, which, as you saw, was not available at this time, but it's calculated by the length of the segment times the the traffic volume, the annual AADT, average annual daily traffic, number of days, which would be 365. This is all divided by 1,000,000, and then the whole thing, the crash count, is divided by this number. Intersection crash rate is similar to segment crash rate, but when we calculate the AADT, we take into account the ADT of the entering segments. And then the crash injury essentially weighed differently, a fatality versus an injury or versus a PDO. This is a formula that's been around for a long time. There's better, newer crash severity measures in research, but we haven't been able to implement any that has been more widely accepted. We'd like to coordinate this with FDOT Safety Office to make sure that we're using similar standardized measure for these results. And with that, I would like to see if there is anything else you'd like to see in the network analysis that would be helpful. You probably have expressed some of that in your questions or comments so far, and Dan's been taking notes on that. But in any event, please let us know if there would be something useful that we can add to make the network analysis more useful, and hopefully you'll start to use it now that you know more about what it can do. Dan, is there any question? I don't see any pressing question from a general question that I probably need to address verbally at this time.
Well, if you can just quickly show the information icon on how to get to the crash type explanation.
Oh, yeah, absolutely. So essentially, we don't have that here in the network analysis. We probably ought to add that. However, if you go to crash event analysis, this is what the standard, this is where most people use. You go to the filters down here under circumstances and crash type. So when you open crash type, then you can click on this little eye. It gives you a short description on how the crash type is calculated, what are the variables here. And then that document, for the actual document I showed you, then you need to just click here for more information. And if we don't, and there it is. If we didn't answer all your questions, since we're approaching the 12 o'clock, we will be looking at all the questions and compile a list with it, including the ones that we didn't cover. And everybody will get back a complete list. They would be all the questions would be anonymous. So that way we want to make sure that everybody get access to the information. There is a question about browser compatibility. That's a good question. As you know, right now, Signal 4 can run either here in Firefox or in Internet Explorer. That is obviously unfortunate because this was developed, started 10 years ago and the technology has changed since. So we are working on what we call next generation Signal 4, which will be working, it's based on HTML5 and that kind of technology. And it will be working in all the browsers. So that is work in progress, and it will take a while before we get that switch. So for now, unfortunately, you've got a couple of choices, either Internet Explorer 10, whatever version, the latest version, or Firefox. And there is a specific version of Firefox. Usually when you hit our login page, you get an explanation if you're not using one of these compatible browsers. We have not sent any links about recordings yet. We're waiting to finish all the webinars. We will compile everything, the list of questions, the slides in one place, and then we'll send you the list. We'll send you all that information, including the link to recordings. So hopefully that will happen after we're completing the webinar later today. We'll probably need a couple of days before we can send it to you. Okay, everyone, at this point, I don't want to hold you any longer. We're close to lunchtime. So I will be closing it here now. And if you're attending the 1 o'clock, then I will talk to you then.